picture we are about to see, we must remember that the explosive power of atomic bombs used in this test was in the kiloton range. The explosive power of today's hydrogen bomb is measured in terms of megatons. What does that mean to us? It's a matter of practical application. It takes 1,000 kilotons to equal 1 megaton. And by applying the scaling laws, the proportionate comparative effects of a larger bomb can be determined. The A bomb exploded here was rated at approximately 30 kilotons. For comparison, let's use a 20 megaton H bomb. The 20 megaton bomb, therefore, would be 667 times as strong as a 30 kiloton bomb. The relationship between distance for any given pressure and the size of nuclear weapons follows the cube root scaling law. So theoretically, a hydrogen bomb of 20 megatons at approximately 8.5 miles would have about the same destructive power as an atomic bomb of 30 kilotons at 1 mile. In this test, many of the structures were approximately 1 mile from ground zero. In the case of a 20 megaton H-bomb explosion, most of these structures undoubtedly would be obliterated. And actually, at a distance of 8.5 to 9 miles from ground zero, with the longer duration of blast pressure, we could expect to find conditions even more severe than those at 1 mile from ground zero in this test. This atomic test, although depicting the severe effects of a nuclear weapon, does not reflect the extent and severity of destruction that would result from a nuclear weapon in the multi-megaton range.
At the Atomic Energy Commission's Nevada test site, I covered the story of Operation Cube, a program to test the effects of an atomic blast upon the things we use in our everyday lives.
Operation Q, the atomic test program of the Federal Civil Defense Administration, as seen by Joan Cowan, reporter.
I had to see Operation Q through many eyes, not only my own, but as a reporter through the eyes of the average American man and woman. I arrived at Civil Defense Headquarters the day before the explosion was scheduled to take place, and checked in at once with the official who was to brief me about the test. To give me a perspective of the entire layout, a member of the Civil Defense staff showed me a carefully prepared model of the site. The scope of the test and the detailed care with which it had been planned amazed me as I listened to the explanation.
We begin with the question of shelter, for shelter might save our lives if we were far enough away from ground zero. If so, what kinds of shelter are effective? Several kinds are to be tested, from elaborate industrial shelters to the box-type shelter in the corner room of a basement. This type would give more room for a family, especially if it were necessary to remain there for several days. In this frame house without a basement, at the 4,700-foot line, we will test a bathroom shelter built of reinforced concrete. The entrance door and outside window covering are designed to resist blast.
I asked about the possible loss of utilities and what this would mean to survivors. No electricity for running a home or an industrial plant.
Loss of power may be one of our biggest problems after an attack. Power poles, power lines, pole transformers, and complete substations are to be tested by the Edison Institute. How will they withstand this blast? How long will it take to make repairs? How soon can service be reestablished? These are things we hope to learn from the test. One complete transformer substation has been erected relatively close to the shot tower. A second substation and power lines have been placed at a much greater distance from the tower.
Thinking about news during an atomic attack, I asked about radio towers.
Two kinds are to be tested. One tower is self-supporting without guy wires. The other has supporting cables. Both types are very common. Nearby, a complete radio transmitter will actually broadcast from tape before the shot to be picked up by radios in the test houses. Both liquefied petroleum and natural gas facilities will be tested. Will the fittings and connections stand the test? Will there be fires? All equipment is installed and checked by technical experts from the LP Gas Association and the American Gas Association. An 18,000-gallon supply tank, partially filled with propane and complete with feed pipes. A weighing and storage house and delivery platform have been erected on the test site.
I was anxious to learn all I could about the various types of houses to be tested.
5 types are prepared for exposure to the blast and heat of this atomic explosion. First, a single-story frame rambler without basement built on a concrete slab. Second, a 2-story masonry with basement constructed of brick backed with 4-inch cinder blocks. Third, a house of 8-inch concrete blocks reinforced with steel. The 4th type is a single-story rambler made of precast lightweight concrete. Walls and roof panels were joined by welding steel lugs. The 5th, at the 5,500-foot line, is a redesigned house similar to one previously tested. This new design provides additional strength at a cost increase of approximately 10%. That's the real purpose of testing these houses, to find their weak points. Through the cooperation of the furniture and appliance industries, household furnishings were installed in the houses. Mannequin families supplied by private industry are to represent Mr. and Mrs. America.
Interior home furnishings donated by industry are complete in every detail. I looked at the mannequins sitting about so indifferently.